9.4 Compositions of isometries. An isometry is a transformation that preserves distance or side length. So translations, rotations, reflections, and then glide reflections are all isometries. There are only 4 kinds of isometries. We already know translation, rotation, reflection, and then we're going to look at today glide reflection. Remember that the composition of transformations is when 2 or more transformations are combined, one performed right after the other. When compositions of transformations are written like this, they are performed in the reverse order of how they are written, meaning that the first item that would be conducted would be the reflection across line L, followed by the reflection across line M. So you would be going from right to left in order of how you perform these. Here it asks, what is the reflection of point J across line L followed by line M? Well, as we see here, this is the original J, and we reflect across line L first. It flips to here, and then one more time it flips back. What they're trying to illustrate here is that reflecting across these 2 lines, which are clearly parallel, results in a translation. It's a translation from here to here. And so this brings us to Theorem 9.2, the reflection across parallel lines. A composition of reflection across 2 parallel lines is a translation. So when you reflect across 2 parallel lines, you get a translation. Lines L and M intersect at the point C and form a 70-degree angle. What is the reflection across line L followed by line M of J? So as we see this, we start here, we reflect across L, followed by across line M. And as we observe this, we see that this is more of a turn than anything else. So in reality, this is a rotation. So a reflection across 2 intersecting lines is a rotation. And then if we look carefully here, we know that the intersection here is 70 degrees, but we actually have 2 extra parts here. So if we wanted to talk about the resulting rotation, this is in reality just a rotation of, well, we double 70, so we get 140 around the center rotation, which would be C. So we're looking at a rotation of 140 degrees around point C. A composition of reflections across 2 intersecting lines is a rotation. So anytime we reflect across 2 intersecting lines, we're looking at a rotation. Lines A and B intersect at C and form a 45-degree angle. What is the reflection of J across these 2 lines? So once again, they go across A and then across B. Our center of rotation is the intersection point C, so we're looking at a rotation of 90 degrees around point C for J there. So this would be our reflection, or a rotation in this case. So a reflection across 2 intersecting lines is equal to a rotation of double the angle of intersection around the point of intersection for whatever you're trying to, in this case, reflect or rotate. A glide reflection is a composition of a translation and a reflection across a line parallel to the direction of the translation. And normally you'll see a glide reflection where you translate and then you reflect across the line parallel, but this isn't always true in some of our examples. Sometimes our translations take us diagonally and we reflect over a line after that, but that's okay. So here we have triangle text has coordinates of -5, 2, -1, 3, and -2, 1. So let's go ahead and plot these points first. So the first thing we want to do is we want to translate it, because we start with the translation here of down 5. So we're going to go down 5. 1, 2, 3, 4, 5. So we'll put these as placeholder points. 1, 2, 3, 4, 5. And then down 5. So this is our placeholder now, because we still have to do the reflection piece. And now we want to reflect over the line x equals 0. Well, x equals 0 is the y-axis in this case. So we'll reflect across that. And so here we've got the point E prime. Then here, T prime, and then X prime is here. And so this is the image of our glide reflection. So we should have coordinates T prime of 5, -3. E prime in this case 1, -2, and then X prime is 2, -4. Second example, this time we have triangle PQRS. So we'll plot PQRS first. So P is at 0, 5. Q is at 5, 3. And R is at 3, 1. So there's our pre-image. And they want us to conduct the glide reflection where we're going to translate -3, -1. So 3 left, 1 down, and then across the line y equals -1. So we'll start with the translation. We'll move 3 left, down 1. 3 left, down 1. 3 left, down 1. And then y equals -1 is the horizontal line at -1. So we're going to reflect across that point. So we'll go down 1, down 1. So here we have R prime. Here we have Q prime. And then we have P prime. And so here's our image triangle. And so we have coordinates of P prime at -3, -6. Q prime is at 2, -4. And R prime is at 0, -2. Problem 3, we have triangle text has coordinates of -5, 2. -1, 3. And -2, 1. So this is our pre-image. And we want to conduct the glide reflection of right 4, and then the reflection over the line y equals -1. So let's go ahead and translate right 4. From there, we're then going to reflect across the line y equals -1, which is a horizontal line at -1. So we go down 2. This is X prime. Then we go down 4. This is E prime, and then T prime. And so this becomes our image of TEX or TEX. So triangle T prime, E prime, X prime. And your coordinates for your prime points would be -1, -4. E prime would be 3, -5. And then X prime would be 2, -3. Okay, so this time we have triangle text again, so we're going to plot the points. -2, 2 is where the T goes. So we got T, -1, 3, and then -2, 0 would be the X. So there's our pre-image. Then they want us to translate it right 1 down 3. So right 1 down 3. Right 1 down 3, right 1 down 3. So this is what our part of our image point looks like. And now they want us to reflect across the line x equals 2, which is a vertical line at x equals 2. And now we just need to reflect across this line. So we've got 1, 2, 1, 2. So here is E prime, 2, 3. Here is T prime. And then 1, 2, 3, 1, 2, 3. Here is X prime. So this is our image points. And so we've got T prime has the coordinate 5, -1. E prime has the coordinate 4, 0. And X prime has the coordinate 5, -3. All right, so in this example, it's asking us to write two transformation rules that explain the mapping from A at 3, 3 to A prime at 5, -4. So the easiest way to do this is to plot these. So 3, 3 puts A here. And then A prime would be 5, -4, which would be right here. So the question is, how do we get from point A to point A prime? One way would be, you could say, a translation by 2 units right. So 1, 2, then down 1, 2, 3, 4, 5, 6, 7. So down 7. There's 1. That's one way to do it. That's one way. You could also do a glide reflection. So think of it this way. We could also move A prime over 2 units, or sorry, move A over 2 units. So translate it 2. So we could say we're going to do a composition of reflections. So we'd say a translation of 2 to the right. And then once we're at this point, we need to get down to that point. Well, to do that, we could reflect over this point here, which would be a reflection across the line, y equals -1/2. There's one way. We can then back up again and say, let's try something else. Well, we could also just bring A down to here at this point. So that would be moving it, translating it down 7, so 0, -7. But before that, or after that, we would then have to reflect across this line here, which is the line x equals 4. There are a lot of ways to do this. You could even throw in some rotations if you wanted to get fancy with the problem. There are a lot of ways to get from A to A prime. Just depends on how creative you want to be. You could do a composition of translations if you wanted to. You could say, let's translate down 7, followed by an additional translation of 2 to the right. It's essentially the same thing as this, but done in 2 steps. So that could work as well.